In this video, we're going to go over some problems that are similar to what's on your Unit 2 test. So remember that your test will be over these lessons: 2.01 Relations and Functions, 2.02 Function Equations, and 2.06 and 2.07 in which we talked about domain and range. So remember, a good way to study for your test is to look over homework problems and rework any problems that you might have missed. Remember to do the practice problems that are in the review assignment that I'm going to be going over in a few seconds. Attend the one-to-one sessions and office hours if you have any questions, and remember that you can also always email me your questions. So let's work on some solutions to the review. So let's look at this. We want to find the domain and range of this relation. So remember that we have our mnemonic, Dixie-roid, which tells us that domain is X and range is Y. So to list out the domain, we're going to list out all of the X values in this table. So all of these values will be the domain. So we have 0, 1, 2, 4, and 5. The range will be all of the Y values, which are all the values in the second column of this table. So when we list them out, we have 1, 4, 7, 13, and 16. So now we need to identify the domain and range of this relation. Remember that in a mapping diagram, the left side will be X and the right side will be Y. So the domain will be all of the values on the left side, which are 3, 4, 7, and 8. And the range will be all of the values on the right side, which are 0, 4, and 9. So now we want to find the domain and range of this relation, and we're given a set of points on a coordinate plane. So it's really helpful sometimes, I think, to list out the coordinate points just so that you know all of the X and Y values. So this first point right here has the point -2, 2. This next point has the coordinates 1, -1. Then we have this point, which is 1, 4. And now finally we have this point 2, -1. So remember, domain is all of the X values, and in coordinate pairs, the X comes first and Y comes second. So I'm going to list out all of the values that come first in each of these ordered pairs. So the domain will be -2, 1. I don't need to write a repeated value twice. So I have 1 twice. I only need to write the 1 once, and then I have 2. The range will be all of the Y values, which are all of the values that come second in each of these ordered pairs. So when I list them out, I have 2, -1, and 4. I have -1 again, but I don't need to write it twice. Remember, in the domain and range, you don't need to write repeated values more than once. So now let's identify which of these relations are functions. So since we have graphs, we're going to need to use the vertical line test. Remember that the vertical line test says that if you pass through more than once, and that's when you draw a vertical line, then it is not a function. More than once, then it's not a function. Okay, so we're going to draw vertical lines, or we're going to use our grid, and we're going to see if any pass through more than once. So this first one is a function. In the second graph, as soon as I start drawing vertical lines, they're going to pass through more than one point. So it is not a function. In this next graph, I can keep drawing vertical lines, and they're only going to pass through once. So yes, it is a function. So let's continue with this idea on this question. So once again, when I start drawing vertical lines here, they're all going to pass through only once. So yes, it is a function. In this graph, as soon as I start drawing vertical lines, they're going to pass through more than once, so it is not a function. It's the same situation with this graph. As soon as I start drawing vertical lines, they pass through more than once, so it is not a function. So now it gives me the function g of x, which is graphed on the coordinate plane. It says, what is g of -3? So remember, this is giving me an x value. So it's saying, what does y equal? Okay, because remember, g of x equals y. So this is saying, what does y equal when x equals -3? So to figure this out, I'm going to go to my graph and find x equals -3. And I'm going to figure out the point that is there. So that is this point, -3, -5. So that means that when x equals -3, y equals -5. So that is why g of -3 equals -5, because that is the value of y when x equals -3. So now let's figure out which tables represent y as a function of x. So remember that in a function, no x can repeat. That is very, very important. So that is going to be our key idea when we look at these tables and figure out which one is a function. So in the first one, I'm looking for a repeated x, and notice here that 4 repeats. So a is not a function. If I look at table B, well, 5.65 repeats, and so does 3.75. So b is not a function. If I look at this next table, all of my values are different, so this one's looking good, but I'm just going to check the last table just to make sure. Once again, I have the 4 that repeats and the 2 repeats, so d is not a function, which is why c is the correct answer. So now in this problem, it says given that f of x equals 8 times 12 minus x minus 5, what is the value of f of -2? So remember, this f of -2 is telling me that x equals -2. And it's telling me to take this -2 and go to my equation and plug in for x. So that is what I'm going to do. So I'm going to rewrite this equation. F of -2 equals 8 times 12 minus -2 minus 5. So remember, I'm going to need to do order of operations in order to simplify this problem. Let's work with what's in the parentheses first. I have 12 minus -2, which will turn into a plus. So this gives me 8 times 12 plus 2, which is 14. So I have 8 times 14 minus 5. 8 times 14 is 112. So I have 112 minus 5, which is 107. So f of -2 is 107. So the graph of part of a linear function is shown on the grid. Write inequalities that represent the domain and range of the parts shown. So remember that the domain is going to be the x values, range is going to be the y values. So in this graph, we need to draw in our boundary lines. So the leftmost point for the domain is going to be here. So I'm going to draw in my boundary line. And then the rightmost point for the domain will be here. So I'm going to draw in my boundary line. So my left, remember I write this going from left to right. So when I write the inequalities, I'm going to go from lowest to highest value. Okay, so the left is going to be the lowest. So that is the value of -2. This is a filled in circle, so I'm going to use a less than or equal to sign. And then I'm going to write x because it is the domain, okay? Because my values go from here to here. And then I'm going to use a less than sign because I have an open circle here at 2, and 2 is my other boundary. So my domain is -2, less than or equal to x, less than 2. Now let's write the range. The range, the lowest value in the range is here, and then the highest value in the range is up here. So let's write that out. The lowest value is -4. I have an open circle at -4, so I'm going to use a less than sign. And remember, we're talking about range, so we're talking about y. And then the highest value is at 4. There is a filled in circle at 4, so I'm going to use less than or equal to. So given this table of values, what is the value of f of 10? So remember, when it's asking us to find a specific function value, it gives us the value of x, and it's saying basically what is y equal. So when x equals 10, I'm going to go to my table, and then here's x equals 10. The y value that corresponds to x equals 10 is 30. So that's why f of 10 equals 30, because that is the value of y when x equals 10. So in this problem, Nancy has 4 gel pens. She plans to buy more from the store. The store sells gel pens in packs of 12, which may not be opened before purchase. The store has 3 packs in stock. The function that models the number of gel pens Nancy will have after her purchase is f of p equals 12p plus 4, where p is the number of packs of gel pens that she buys. What is the domain and range of this function? So let's start off by highlighting the important information. So she has 4 gel pens to start off. She wants to buy more from the store. The store sells gel pens in packs of 12, which may not be opened before purchase. So we know she's going to be buying whole packs. They have 3 packs in stock, and then the function that we have is f of p equals 12p plus 4. And we're trying to find the domain and range. So remember, when we're talking about these kind of word problems, our first question is this discrete or is this continuous? So remember, the distinguishing factor that we have is, can we have a half a pack? Can we have a fourth of a pack? Can we buy partial packs? Well, it says that it may not be opened before purchase. So we're going to say that this is not continuous and it's going to be discrete because I can only buy whole number amounts of packs, right? So we're going to assume that she's going to buy at least one, okay? Because she's going to go to the store and she's going to buy more pens. Well, she can't buy any more than 3, right? Because they only have 3 packs in stock. So she can buy 1 pack, or she can buy 2 packs, or she can buy 3. So remember, our domain is going to be the input values. Let's look at the function f of p equals 12p plus 4. What is the input value in this function? Well, based on how it's written, we can see that p, which is the number of packs, is the input. F of p, which is the total number of gel pens she has, so F, let's say number of pens, is the output. Okay, so packs is represented by P, number of pens is represented by F. So since P is the input, remember from Dixie Royd that the domain is the input and range is the output. So the domain will be represented by P, which is the input, and then F, which represents the number of pens, will be the output. So we've already listed out the values in the domain. Since she's going to the store, we've said she's going to buy at least 1 pack. She can buy 2 packs if she wants, but she can't buy any more than 3 because that's all they have at the store. Now we need to figure out the range values that correspond to these domain values. So to figure this out, we're going to have to plug in for each domain value, right? So we have these domain values of P, which are 1, 2, and 3. And then we have F of P, which are our range values. So when we plug that in, we get F of 1 equals 12 times 1 plus 4, which is 16. So that is the first value in our range. Then we have F of 2, which equals 12 times 2 plus 4, which is 28. So that is the second value in our range. We also have F of 3, which is 12 times 3 plus 4, which is 40. So she can also get 40 pens. So that is how you describe the domain and range of this function. So now we have another problem. Alex works at the local movie theater after school. He works for at least 3 hours, but no more than 12 hours in a week. The function f of h equals 7.5h represents the amount of money he earns for working h hours. What is the domain and range of this function? So let's look at the important information. He works at least 3 hours, but no more than 12. We have this function, and then we are finding the domain and range. So the first thing, remember, just think about whether this is discrete or continuous. So the idea here is we're talking about how much money he earns and how many hours he works. So when we're talking about money and hours, can we have half an hour? Can we have a fourth of an hour? Yeah, we can, right? When we talk about money, can we have like half a dollar or a fourth of a dollar? Yeah, we can. Okay, so this is going to be continuous because we are allowed to have decimals and fractions and things like that. So it's going to be continuous, so we know we need inequalities. Okay, now let's figure out the input and output values. We have the function f of h equals 7.5h. So we have the input values of h and we have the output values of f. So h represents the hours he works, and then f represents the money he earns. So since h is our input, that is going to be our domain, and then f is going to be our output, so that is going to be our range. So domain will be h, range will be f. Let's think about all the possible values in the domain. So how many hours does Alex work? Well, it says he works at least 3, but no more than 12. So we're going to start off with the lowest value at 3, which is going to be less than or equal to h, but no more than 12. So h is going to be less than or equal to 12. That is our domain. So now we need to figure out the values in the range. So since we have an inequality, we just need to figure out the highest value and the lowest value. So the lowest value will be f of 3, which equals 7.5 times 3. And that is $22.50. Then we need to figure out the highest value, which is f of 12. So that's 7.5 times 12, which equals $90. So our range is going to go from $22.50, less than or equal to f, or you can write f of h, which is less than or equal to 90. So that is the domain and range of this function. So in this problem, it asks us to figure out which table represents y as a function of x. So remember that we don't want no x to repeat. Okay, so no repeated x. So that is going to be what we're looking for when we look at these tables. So here in this first table, we have -9 and -9, which repeat. Here in the second table, 9 and 9 repeat, so that is not a function. C, it doesn't look like any values repeat, so we're going to leave that. And we're just going to double check D, where we see that 1 repeats. So D is not a function. That is why C is the correct answer to this problem. Now given h of x equals 14x minus 7, what is the value of h of 6? So what we're going to do is, once again, this is telling us a value of x, and we're going to take that x and we're going to plug it into this equation. So we have h of 6 equals 14 times 6 minus 7. 14 times 6 is 84. So we have 84 minus 7, which is 77. So h of 6 equals 77, and that is the value of this function.